Whether a maintenance person with no formal electrical training can install tap cans into busways or bus ducts after receiving manufacturer-specific training depends on several factors. Firstly, the Occupational Safety and Health Administration, known as OSHA, defines a qualified person as someone trained and demonstrably skilled and knowledgeable in this specific electrical tasks. While manufacturer training on bus plug installation is valuable, it might not fulfill OSHA's broader qualified person definition. Secondly, under certain conditions, such trained maintenance personnel may be considered qualified. If the manufacturer's training is comprehensive, covering all task aspects and hazard mitigation, it could meet qualified person requirements. Documentation and refresher training are crucial for sustained competency. Thirdly, the electrical code in the work jurisdiction dictates specific requirements. Some codes permit non-licensed personnel to perform limited electrical tasks with appropriate training, while others mandate full licensing or apprenticeship. Consulting the relevant electrical code is essential. The National Electrical Code, known as the NEC, doesn't specifically address non-qualified personnel plugging in bus plugs. Evaluating the manufacturer's training program against relevant electrical codes and industry standards is crucial. It's good practice to have a licensed electrician or qualified electrical supervisor oversee non-licensed personnel's work to ensure safety and compliance. Regular audits and inspections should assess non-licensed personnel competence and compliance with electrical safety regulations. The Occupational Safety and Health Administration guidelines are paramount in determining who is considered a qualified person to perform electrical work. The definition of a qualified person as it pertains to electrical work is someone with the skills and knowledge related to the construction and operation of electrical equipment and installations and who has received safety training to recognize and avoid the hazards involved. This definition is critical in determining whether an individual is competent to perform tasks such as plugging in tap cans or bus plugs into busways or bus ducts. Manufacturer-provided training, while valuable, needs to be assessed against this standard. The training's comprehensiveness is a key factor. Does it cover not only the physical act of plugging in the tap can but also a thorough understanding of the electrical system, potential hazards, and safety procedures? The training should equip individuals with the ability to identify exposed energized parts, understand the concept of arc flash and arc blast, and demonstrate the appropriate use of personal protective equipment, known as PPE. The training program should also include instruction on how to de-energize equipment, verify the absence of voltage, and implement lockout-tagout procedures, known as LOTO, when necessary. The level of detail and practical application provided in the training is important. A qualified person should be able to troubleshoot common problems, understand the ratings and limitations of the busway system, and know when to seek assistance from a licensed electrician or qualified supervisor. Training should also emphasize the importance of following established safety protocols and procedures and the consequences of not doing so. Documentation of training is essential. Employers should maintain records of the training provided to maintenance personnel, including the topics covered, the dates of training, and the names of the instructors. This documentation serves as evidence that the employees have received the necessary training to perform the task safely and competently. Regular refresher training is also crucial. Electrical systems and safety standards can change over time, so it's important to provide employees with periodic updates to ensure their knowledge and skills remain current. The frequency of refresher training should be determined based on the complexity of the task, the potential hazards involved, and the employee's level of experience. In addition to Occupational Safety and Health Administration guidelines, local and national electrical codes play a significant role in determining who can perform electrical work. The National Electrical Code sets standards for the safe installation of electrical wiring and equipment. While the National Electrical Code doesn't specifically address the issue of non-qualified personnel plugging in bus plugs, it does emphasize the importance of qualified individuals performing electrical work. Many local electrical codes require individuals to be licensed or certified to perform electrical work. These licensing requirements are designed to ensure that individuals have the necessary training and experience to perform electrical work safely and competently. It is crucial to consult the relevant electrical code in the jurisdiction where the work is being performed to determine the specific requirements for who can perform electrical work on busway systems. Even if the local electrical code doesn't explicitly require licensing for plugging in bus plugs, it's still important to ensure that individuals performing this task have received adequate training and are competent to do so safely. This can be achieved through a combination of manufacturer-provided training, on-the-job training, and supervision by a licensed electrician or qualified supervisor. It is also a good practice to conduct regular audits and inspections of the work being performed to ensure compliance with electrical safety regulations. These audits should assess the competence of non-licensed personnel, the effectiveness of the training program, and the overall safety of the electrical system. Any deficiencies identified during the audit should be addressed promptly and effectively. The manufacturer's training program is a critical component of ensuring that non-licensed personnel can safely plug in bus plugs or tap cans. The program should be comprehensive, covering all aspects of the task, including electrical hazards, safety procedures, and troubleshooting techniques. The program should also be regularly updated to reflect changes in technology, safety standards, and electrical codes. The training program should include both classroom instruction and hands-on training. Classroom instruction should cover the theoretical aspects of the task, such as electrical theory, safety regulations, and troubleshooting techniques. Hands-on training should provide individuals with the opportunity to practice the task under the supervision of a qualified instructor. The training program should also include a written exam and a practical exam to assess the individual's understanding of the material and their ability to perform the task safely and competently. The National Fire Protection Association, known as NFPA 70E standard for electrical safety in the workplace, provides guidance on how to develop and implement a comprehensive electrical safety program. This standard covers topics such as hazard identification, risk assessment, personal protective equipment, lockout-tagout procedures, and training requirements. The NFPA 70E standard is widely recognized as the industry standard for electrical safety and is often referenced by Occupational Safety and Health Administration in its enforcement activities. Employers should consult the NFPA 70E standard when developing their electrical safety program and ensuring that their employees are adequately trained to perform electrical work safely. In addition to training, supervision is another important factor in ensuring the safety of non-licensed personnel who are performing electrical work. Supervision should be provided by a licensed electrician or qualified electrical supervisor who has the knowledge, skills, and experience to oversee the work being performed. The supervisor should be responsible for ensuring that the non-licensed personnel are following established safety procedures, using the appropriate personal protective equipment, and performing the task safely and competently. The supervisor should also be available to answer questions, provide guidance, and troubleshoot problems. The level of supervision required will depend on the complexity of the task, the potential hazards involved, and the experience level of the non-licensed personnel. For simple tasks with minimal hazards, a lower level of supervision may be sufficient. However, for more complex tasks with greater hazards, a higher level of supervision will be necessary. It is also important to remember that the ultimate responsibility for electrical safety rests with the employer. Employers have a legal and ethical obligation to provide a safe working environment for their employees. This includes providing adequate training, supervision, and personal protective equipment, as well as implementing effective safety procedures and policies. Employers should also conduct regular audits and inspections to ensure compliance with electrical safety regulations and to identify and correct any potential hazards. Busway systems, while offering flexibility and convenience in power distribution, present inherent electrical hazards that must be carefully managed. One significant hazard is the potential for electrical shock. Busways typically operate at high voltages, often 480 volts or higher, making contact with energized parts potentially fatal. Proper insulation and guarding are crucial to prevent accidental contact. Workers must be trained to identify exposed energized parts and maintain safe distances. The use of appropriate personal protective equipment, such as insulated gloves and safety glasses, is essential when working near busways. Arc flash is another serious hazard associated with busway systems. An arc flash is a dangerous electrical explosion that can occur when a fault develops in the electrical system. Arc flashes can generate extremely high temperatures, intense light, and pressure waves, causing severe burns, eye injuries, and even death. Workers must be trained to recognize the signs of a potential arc flash hazard, such as loose connections, damaged insulation, and signs of overheating. Arc flash hazard assessment should be conducted to determine the potential arc flash energy levels at different locations in the busway system. Based on the results of the assessment, appropriate arc flash personal protective equipment should be selected, such as arc-rated clothing, face shields, and gloves. Lockout-tagout procedures are essential for energizing busway systems before performing any maintenance or repairs. Lockout-tagout involves disconnecting the power source, locking the disconnect switch in the off position, and attaching a tag to the switch indicating that the equipment is out of service. This prevents accidental energization of the equipment while work is being performed. Workers must be trained on proper lockout-tagout procedures and must follow these procedures meticulously to ensure their safety. Overloading busway systems can also create hazards. Busways are designed to carry a specific amount of current. Overloading the system can cause the conductors to overheat, leading to insulation damage, equipment failure, and even fires. It is important to ensure that the load in the busway system does not exceed its rated capacity. Regular inspections should be conducted to check for signs of overloading, such as overheating, discoloration, and unusual noises. Proper grounding is essential for the safe operation of busway systems. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and de-energizing the system. This helps to prevent electrical shock and equipment damage. Busway systems should be properly grounded in accordance with the National Electrical Code and other applicable standards. Regular inspections should be conducted to ensure that the grounding system is intact and functioning properly. In addition to these specific hazards, there are also general electrical safety hazards that workers should be aware of when working near busway systems. These include the hazards of working in wet or damp locations, the hazards of using damaged or defective equipment, and the hazards of working near overhead power lines. Workers should be trained to recognize these hazards and take appropriate precautions to prevent accidents. The type of busway system used can also affect the potential hazards. There are two main types of busway systems: enclosed busway and open busway. Enclosed busway systems are designed to protect the conductors from physical damage and accidental contact. Open busway systems are more exposed and require greater care to prevent accidents. Workers should be familiar with the specific hazards associated with the type of busway system they are working on. It is important to remember that electrical safety is an ongoing process. Workers should be continuously trained and reminded of the potential hazards associated with busway systems. Regular inspections should be conducted to identify and correct any potential hazards. By taking these precautions, it is possible to minimize the risk of electrical accidents and ensure the safe operation of busway systems. When evaluating a manufacturer's training program for busway tap installation, several key elements should be present to ensure comprehensive and effective training. The training should begin with a thorough overview of electrical safety principles, including the dangers of electrical shock, arc flash, and other hazards. Participants should learn about the importance of de-energizing equipment before working on it, using appropriate personal protective equipment, and following established safety procedures. A detailed explanation of busway systems is crucial. This should cover the different types of busways, their components, and their applications. Participants should understand the voltage and current ratings of the busway, the importance of proper grounding, and the potential hazards associated with overloading the system. The training must include step-by-step instructions on how to safely install busway taps. This should cover the proper procedures for selecting the correct tap size, preparing the busway for installation, installing the tap, and tightening the connections. Participants should learn how to use the appropriate tools and equipment and how to avoid damaging the busway or the tap. The training should emphasize the importance of proper torquing techniques. Over-tightening or under-tightening connections can lead to loose connections, overheating, and potential electrical failures. Participants should learn how to use a torque wrench to tighten connections to the manufacturer's specifications. The training should also cover troubleshooting techniques. Participants should learn how to identify common problems with busway taps, such as loose connections, damaged insulation, and signs of overheating. They should also learn how to safely troubleshoot these problems and how to prevent them from recurring. Hands-on practice is essential. Participants should have the opportunity to practice installing busway taps under the supervision of a qualified instructor. This allows them to gain practical experience and to develop the skills and confidence needed to perform the task safely and competently. Training should include a written exam and a practical exam to assess the participants' understanding of the material and their ability to perform the task safely and competently. Participants who pass the exam should receive a certificate of completion. The training should be regularly updated to reflect changes in technology, safety standards, and electrical codes. Participants should receive refresher training periodically to ensure that their knowledge and skills remain current. The training program should be documented, including the topics covered, the dates of training, the names of the instructors, and the results of the exams. This documentation can be used to demonstrate compliance with occupational safety and health administration regulations and other applicable standards. The manufacturer's training program should be evaluated by a qualified electrical professional to ensure that it meets the requirements of the National Electrical Code and other applicable standards. The evaluator should review the training materials, observe the hands-on training, and interview the instructors and participants. Based on the results of the evaluation, the training program may need to be revised to address any deficiencies. The specific requirements for electrical safety can vary depending on the jurisdiction. It is important to consult with local authorities to determine the applicable requirements in your area. This may include licensing requirements, permitting requirements, and inspection requirements. Compliance with these requirements is essential to ensure the safety of workers and the public. When working on busway systems, it is essential to use the appropriate personal protective equipment. This may include insulated gloves, safety glasses, arc-rated clothing, and other equipment. The specific personal protective equipment required will depend on the potential hazards involved. Workers should be trained on how to properly use and maintain their personal protective equipment. Lockout-tagout procedures are essential for de-energizing busway systems before performing any maintenance or repairs. Lockout-tagout involves disconnecting the power source, locking the disconnect switch in the off position, and attaching a tag to the switch indicating that the equipment is out of service. This prevents accidental energization of the equipment while work is being performed. Workers must be trained on proper lockout-tagout procedures and must follow these procedures meticulously to ensure their safety. Regular inspections of busway systems are essential to identify and correct any potential hazards. Inspections should be conducted by a qualified electrical professional. The inspection should include a visual inspection of the busway, a check of the connections, and a test of the grounding system. Any deficiencies identified during the inspection should be addressed promptly and effectively. The results of the inspection should be documented. In addition to the above considerations, there are a few other points to keep in mind when dealing with busway systems and the qualifications of personnel working on them. Firstly, insurance requirements may dictate specific qualifications for personnel working on electrical systems. Insurance companies may require that only licensed electricians or qualified personnel with specific training perform certain tasks to ensure coverage in case of accidents or incidents. Secondly, company policies and procedures may further restrict who can perform certain electrical tasks. Even if not legally required, a company may choose to implement stricter policies to ensure a higher level of safety and compliance. Thirdly, it's essential to consider the potential consequences of improper installation or maintenance of busway systems. Electrical failures can lead to equipment damage, production downtime, injuries, or even fatalities. Therefore, it's crucial to prioritize safety and ensure that personnel working on these systems have the necessary knowledge, skills, and experience. In summary, whether a maintenance person with no formal electrical training can install busway taps after receiving manufacturer-specific training depends on a combination of factors, including occupational safety and health administration guidelines, local electrical codes, manufacturers' training program content, and company policies. It's crucial to carefully evaluate these factors and prioritize safety to ensure that only qualified personnel perform electrical tasks on busway systems.